All right, guys, today we're going to be looking at putting the skills together that we've been looking at over the past week of combining like terms and distributive property. So there are going to be variable expressions that you'll come across that when you're asked to simplify, you need both of these skills. So to quickly review, the first skill that we reviewed was combining like terms. And remember, guys, terms are basically just individual parts of a phrase. So if I had something like 4x 3x minus 7. Again, your terms are your individual parts. So if you remember, we highlighted or boxed them off. So we'd have 4x, 3x, and a negative 7 or minus 7, however you kind of look at it. And again, when we're combining like terms, we're looking at what terms or what boxes have the same variables to the same degree. So if we look, these first two terms, these first two boxes here have an x value, have an x variable, so I would put those together. So 4x plus 3x. So we're going to add or subtract the coefficients. In this case, it's a plus because of the positive 3. So 4 plus 3 is 7x. And then this last box here at the end, the minus 7 or subtraction of 7, negative 7, however you look at it, doesn't have any other like boxes, like terms. So we would just add it or simply rewrite it to the end of that phrase. So my simplified expression would be 7x minus 7. So again, we're going to look for boxes, look for terms that have exactly the same variable, and then we're going to add or subtract the coefficients. So kind of looking at another example real quick, if I had something like this, again, similar in nature, again, if it helps you to box the terms or underline the terms, but I do think it helps you kind of see the individual parts. And again, we would be looking at which boxes are the same, which terms are the same. You should notice the second one and the third box both have an x variable, so I would put those together. 2 doesn't have anybody to combine with, so we would just rewrite the 2. And then a negative 7 and a positive 4, we would say negative 7 plus 4, which is going to give us an answer of negative 3. So negative 3 is the same as a minus 3. And don't forget to put your variable with it. So that was a quick review of combining like terms. We also looked at the distributive property, which is when you multiply a term outside of parentheses to all of the terms inside. So if we had, say, a positive 4 and a parenthesis, 2x minus 8, we would use those arrows. Those are probably familiar to you. And it's basically two multiplications, two simple multiplication problems, and you put your answers together. So 4 times 2x is going to give us 8x. And then we take the second multiplication, 4 times, and we've talked about several times that you include the sign out front. So again, if I look inside those parentheses, I kind of do have two terms, right? I have a 2x, which we multiplied already, and then I have a subtraction of 8 or a negative 8. So when you go to put it in your calculator, you're going to say 4 times negative 8, and we get the answer of negative 32. So again, negative 32, when I buddy it up to my 8x that I already had as part of my answer, it becomes a subtraction, right? And that's exactly what you're going to do. You're going to treat your distributive property as kind of two separate multiplication problems that your answers are combined for your simplified expression. And again, when you put them next to each other, the sign of your answer does appear or can be read as the operational symbol. All right, so let's take a look at simplifying methods. So which simplifying method would you apply to these variables, combining like terms or distributive property? So for guys, if you're watching this video on your own, this is an interactive portion for our live instruction. But if we're looking at this first problem here, 4x plus 3x minus 2 plus 4, what I'm asking of you, and this is kind of mimicked in your practice activity, is would you use the combining like terms or would you use the distributive property to simplify? All right, hopefully you were able to determine that this would be a problem where I have combining like terms. Distributive property, remember, is most likely symbolized by parentheses, but not always. So in this one, you should see that you do have like terms. You've got x values, and we also have regular numbers. So this would be a problem where we would just simply combine like terms. And I'm going to be asking you just to use abbreviations. So on your assignment, you will see something similar to this. You can just write CLT, combine like terms. All right, taking a look at the second example here. We have 3 times the quantity 3x minus 7. So again, which property, which simplifying method would you apply to these variables? Hopefully you chose the distributive property because you do see parentheses, but you see a multiplication of a single term out front, which means that you would need to multiply to both terms inside. So that would be a distributive property. And again, you can use the abbreviation DP, distributive property. All right, looking at that middle example, take a minute, get in your brain, which one would you use, combining like terms of distributive property? Hopefully you chose combining like terms because again, I do not have any parentheses first off, and second off, I do have things that are the same in here that you could put together. All right, looking at the fourth example there, 3x squared minus 3x plus 2x squared. All right, although you do see parentheses here on the back end, if you look up front, it's a plus sign. So there's not really a multiplication of anything there. So this again would be another combining like terms problem. In this example, these parentheses are basically separating signs. All right, and then the last problem there, 6x times the quantity 3 minus x. All right, this would be another example of distributive property. We have a term right out front of our parentheses, buddied directly up to that parenthesis. So that would indicate multiplication as the operation, which would mean that we need to distribute it. So hopefully you did pretty well at identifying the simplifying method that would apply. All right, so as I mentioned, we're going to be looking at expressions that require both techniques and have the properties you looked for above. So you're going to see in these problems things that you can combine together and terms that you need to distribute. So when we are looking at simplifying these types of problems, we want to distribute first. So we want to use the distributive property first. And then we want to combine like terms. And guys, if you think about order of operations, multiplication comes before addition and subtraction. So that's why we also use the distributive property first. It all roots back to the order of operations. So let's take a look at 3 examples together. So again, if I look at example 1, 2 times 6x minus 4 plus x. First, we're going to distribute and then rewrite those extra terms. So you should notice that here is my distributive part of my expression. So we're going to take a minute and we're going to distribute that first term. And again, it's kind of like 2 separate multiplication problems that we're butting up our answers. So 2 times 6x is going to be 12x. And then if we look at multiplying for my second term here, we have 2 times negative 4. Even though you may think to yourself, wait, that's subtraction. Think of it as a negative when you're multiplying so that you get the correct answers. So 2 times negative 4 is going to give you an answer of negative 8. And again, when you write that there on that second line, you can kind of see that if I asked you now, you'd probably say that negative looks like a subtraction. And either way is correct. It's how your terms are buddied up. When I put that orange term next to my pink term, it becomes more of a subtraction type problem to us. And then if you look, there is a plus 8 just kind of hanging out here on the end. When it says rewrite extra terms, we're just going to simply write it down, plus x. So that's the first step, is to distribute. And then the second step, we're going to look at combining like terms. So again, you see 3 color terms there, 12x minus 8 plus x. You should hopefully be able to identify that my x terms are like terms. And again, if we do not have a number outside of a variable, we can know that it's a number 1. We have just x, it's the same as 1x. So if I'm putting together my like terms, we have 12x plus 1x, which is going to give us 13x. And then this time, this minus 8 or negative 8 just simply gets rewritten down below. It doesn't have anybody to combine with. So my simplified algebraic expression there is 13x minus 8. All right, taking a look at the next one. Again, same kind of idea. We're going to distribute and rewrite extra terms, then combine like terms. So the first one, negative 2 times x is negative 2x. Then if I look at my second multiplication, negative 2 times positive 5 gives me an answer of -10. And again, use the calculator to support your computations, guys, if you need it. So -10 is like a -10 when I buddy it on up. And then the last term here is a -4x. So I'm going to go ahead and just rewrite that because it's not part of my distributive property, but it's part of my expression. And then when we look, you should acknowledge that, hey, there are like terms I can put together. I can actually take it a step further and simplify. So hopefully you're able to see that there are 2x terms in here. And again, do you notice how I'm boxing the symbols in front? That's very important that you don't lose those symbols. So -2x minus 4x gives us -6x. And then that -10 just drops on down. It's a regular integer number, and it doesn't have any other like terms to combine with. So here, -6x minus 10 is your finalized simplified variable expression. All right, take a look at this last one here. So think about what term needs to be distributed. That's what I have in that thought bubble there. If we remember what the distributive property is that we take the term right out front of our parenthesis and we multiply it. Right? So you write or you could draw your arrows in if you're doing it on paper. But if we think about what needs to be distributed, and if we talk about, kind of boxing off individual terms, I've got an x term. And we always include the sign out front, right, guys? So even if I just highlight the first part of that expression, -3 is the term, actually. -3, -3. That is the term that needs to be distributed. So we're going to first take a look at just rewriting what we don't need. So this x term, it's just kind of a lone term out there. You don't need to do anything with it yet. That's my rewriting of extra terms. That's not what's being distributed. Then we're going to go ahead and distribute, but we're going to distribute the -3. So -3 times x is -3x. And then if I move on to my second multiplication here, -3 times -4. So do you see how we have two negatives? -3 times -4. That's going to give me a positive 12. And again, guys, if you do it on your calculator, you're going to get just 12. Just the answer of a good old 12 is going to come up. When we go to buddy that up on or put it onto my expression, I need a sign with it. And so just make sure to put your plus sign in here when you are writing it down. Then from there, looking about combining like terms, you should again see two terms that are an x. We have an x and we have a -3x. So putting those together, again, remember if there's no number out front, we can assume it is a 1. So 1 minus 3 is a -2x. And then plus 12, we're just going to rewrite it down below. It's just a regular integer that doesn't have any friends or anybody to combine with. So these are some examples of distributive property and combining like terms put together. If you need more help, please reach out. For your assignment, you're going to be kind of a combination. You're going to have some problems where you're just telling me what is the simplifying method that you see. And then you're going to have some problems like the 3 examples that we just did, where you're actually doing both of them in the same variable expression to simplify. So you're going to always distribute first and rewrite any extra terms that are kind of just hanging out in the expression. And then you're going to look for terms that are alike and combine those. So distributive property first, and then combining like terms. Good luck. Reach out if you need any help.